Welcome to the PhysicsPlace, the place to learn about physics. And in this video I'm going to tell you what the model of an atom is. Also I'm going to show you the correct notation of an atom and what isotopes are. This is a simple model of an atom. As you can see, there are three different kind of particles you need to know. In the middle we have the green and the blue ones, and around it we have the red ones. The middle we also call the nucleus. In the nucleus you can find two kind of particles, and around it there's one particle moving around the nucleus. So in the middle we have this green one with a plus. This is called a proton. We have the blue one, which is called a neutron, and we have the red one with a minus, which is called an electron. Of course, in real life they don't have colors, but this is how we now show them in this model. Now there's a few things you need to know about these particles. First of all, their relative mass. The relative mass is not the real mass they have, but the mass if you relate them to each other. So if we say that the proton has a mass of 1, then the neutron has also a mass of 1. In real life they're very close together with the mass. There's a small difference, but we can say that they both have a mass of 1. The electron is a few thousand times lighter, so we will call it a 0. So it has a relative mass of 0. That doesn't mean it doesn't have any mass, but the mass is very, very small compared to a proton and a neutron. So the proton and neutron both have roughly the same mass of 1, and the electron doesn't have any mass in this model. The second thing you need to know about these particles is their charge. A proton has a positive charge of +1. A neutron is neutral, so it doesn't have any charge, and an electron has a negative charge of -1. Now I will show you the correct notation of this atom. For the correct notation we need to follow this rule. The X is for the symbol of the element. The capital A is the nucleon or the mass number, and the capital Z is the proton number. So if we want to have the correct notation for this atom, we need to calculate the amount of protons. As you can see, there are 3 protons, so we write down 3. Neutrons, we can count 4, so that's 4 of them, and electrons, there's 3. We do not need them for the notation, but just to make it complete I also put down the number of electrons. So now the nucleon or the mass number. As you remember, a proton and a neutron both have a mass of 1. An electron does not have any mass. So 3 plus 4 is 7. The proton number is the number of protons in this atom. As you can see, there's 3 protons, so we will write down 3. So if we put these numbers into this one, we will get 3, 7, and now we only need the symbol of the element. Therefore, we need this table. We are going to look for an element with 3 protons. So if you look at the protons here, you see that lithium has 3 protons, so this is lithium, or Li. This is the correct notation of an atom. But it can also be notated like this, lithium-7, so not -7 but -7, where the 7 stands for the nucleon or mass number. As you can see, there's no number 3, so there's no proton number, but lithium cannot have a different proton number than 3. If it would have a proton number of 2, it would be helium. If it would have a proton number of 4, it would be beryllium. So a number of 3 is always lithium. So if we are talking about lithium, you automatically know that it has 3 protons. If that amount of protons would change, then the symbol would change and it would be a different element. This is not the case with neutrons. Neutrons can change, and therefore we will go now to isotopes. So I'm going to explain what isotopes are. Here we have the previous atom, so the lithium-7 atom. Here we have another atom, and we are going to determine which one this is. So we count the amount of protons. There are 3 protons in there, so it's also a lithium element. And there are 3 neutrons, so the mass is 6. So it will look like this, 3, 6 lithium, or lithium-6. So as you can see, it's the same element, so all the properties are the same for both of these atoms, but the mass is different. This one has a little bit of lighter mass. These 2 elements are now called isotopes. Isotopes are of the same element, but with a different number of neutrons, so they have a different mass. But all properties are the same. This one is just a little bit more heavy. There now will be 2 example questions to check if you understood. Give the correct notation for carbon-12 and carbon-13. Try this for yourself and pause the video now. We will start with carbon-12. Carbon-12 has a mass number of 12, so we will write the capital A here, the 12. Then we can see that carbon has a symbol of C, so we will write down C. And we can see that the proton number Z is 6, so we write down 6. So this is the correct notation of carbon 12. We will do the same for carbon 13. Carbon 13 has a mass number or nuclear number of 13. Also carbon, so a capital C, and now we can also see that it has 6 protons, so we write down a 6. So remember, they are both carbon elements, but this one is a little bit more heavy, but their properties are the same. These are isotopes of each other. Now we will continue with the next question. Give the correct notation of the atom below. So here you have an atom, and here you have the table, and try to give the correct notation. So pause the video now. I will first count the protons. If you count the protons, you can count that there are 5 protons. So we now know that it has 5 protons, and looking at this table we now know that it's boron. So we write down the capital B. Now we need to determine the mass number or the nuclear number. Therefore we need to add the protons with the neutrons. Counting the neutrons in the middle, we can count 6 neutrons, plus the 5 protons is a mass number of 11. So this is the correct notation of this atom. That's it. You should now know what the model of an atom is, what the properties are for protons, neutrons and electrons, and how you can notate the different kind of elements. And of course also what isotopes are. If you found this video helpful, please let me know by liking and of course subscribe for more videos. Thanks for watching.